Hello everybody and welcome to this YouTube channel. Today we will be talking about the small Arduino projects, the types of boards that you can get to make smaller electronic projects. And the first thing I want to do is just show this watch that I was working on. And this is a watch using an Arduino board, a small Arduino board, an RTC module, a real-time clock module, and a Neopixel ring. And it's all compacted, a wooden circular board, the actual circuit board and the wiring, and then the Neopixel ring on top. And then we have the buttons coming out from that onto the actual wristband. And the battery is actually underneath, sewed in between the band. And it comes out as sort of a steampunk style watch. And before we get into what was used to make it and all the parts and the schematics, I first just want to show you how this works. So on the side of the watch you'll see a small switch, and when you push that down it starts the Arduino board. It's basically the power switch, and you can see the power light on the board. And then here, now you can see the Neopixel lighting up. Whenever it starts with blue, that's for hours. So right down here that's 6 lights, and then here would be 7 lights. So that means it would be 7 o'clock, it'd be 7:05, because each pixel in red, when it starts with red, represents 5 minutes. And here you can see that it is 7:08. So what it does is approximate the minutes. So when it gets to about 7:09 or 10, it will go to the next light for 7:10. And then this is not the only thing that it does. These buttons can do various things as well. So the first button is for changing modes. So if I press this first button once, you can see it changed into this mode. Now in this mode, the green represents seconds, and whenever it gets around it, that means 1 minute has passed. And the red still represents the minute, and the blue represents the hour. And the colors actually can overlap. For example, the red and green just overlapped and created a yellow color. Now, when you press the mode again, you have a flashlight. And this can actually get more useful, as I'll show in a second after I get through all these modes. Now the almost last mode is a mode where it's just blinking, sort of a strobe light. So that is just some cool effect I wanted to add in. And then the last one is just a simple color morphing effect. It just goes through all the colors, RGB colors, and later on it actually does another neat effect as well. Now that is all the modes. You can go through all of them again, and it just repeats. And the other thing that you can do, the first thing that you can do is you can actually change the brightness on this thing. So the second button, you can press down and long press and just have it get brighter and brighter, and you can just repeat as you go through the full brightness to most dim. And this actually gets surprisingly bright. You can't really even look at it when it's in its full brightness. And that is why the flashlight can be more useful than it looks, because it actually does get extremely bright. And you can actually see stuff pretty well at night with this brightness. Now the last thing on this watch that I would like to show as far as the programmed code is changing the time. And you can do this by long pressing on the first button. And you can see as I long press, it goes in a circle to show when it's gotten through a full long press. And now it's gotten through a full long press, and you could either press the top button to switch to minutes, or the bottom button to change the hour. So let me just show you. I'll press the bottom button, and it goes through the hour. And I want to just go back to 7. And then when you press the top button, it goes to minutes. So as you can see, it's at 10 right now, and I could go through and change that as well. So that's about it for as well as the code. I do want to add a new mode in the future that would act as a stopwatch. And one thing cool about this is that you can still access the code because there is still a mini USB port sticking out from the bottom. The next thing I want to show regarding this watch is how it's charged. And this is a charger that I bought for the battery that is used in the watch. And I created a way where there is direct access to the battery so that I can still charge it. So here's the charger. It's a USB charger, and you could first just plug in. I have these two female to female wires, and you first just plug it in to each side of the charger, the wires on the charger, and then you can plug it into the actual USB charger. And then on the watch there are these small pins sticking out, as you can see right here. They're just 2 pins sticking out. And what you can do is just connect this up to the charger in the right direction. And in this case, it would be directly from the left to the left and the right to the right with it upside down. And there you can see, if you can see the charger, it's on red, meaning it is charging. And once it's done charging, it will go to green. So you can just set it there and let it charge. So when I first started to look into creating this project, I ordered this Arduino Gemma, and this thing was pretty small and well designed, but the problem was it didn't have enough data pins. It only has 3 data pins, 3-volt ground and volt out, so it just wasn't suitable for the project I wanted to create. I was thinking of maybe compromising some way, but I did not find a way in order to do that. So the second one that I ordered was this one. Now this one's a little bit smaller, and it has more data pins. It has 5 working, fully functional data pins. And the 5th one, I'm actually not sure what it's for, because it doesn't really work as a functional data pin. So this one was more suitable for the project. As you can see that this was slightly smaller, a bit smaller. But I was thinking about using the Flora, but it was a little bit bigger than this, and so it would have been a lot bigger of a watch, and it would have been a lot larger. So I ordered this one, and I will leave the link in the description where you can get all these parts. The next major part in this project was the real-time clock, and the first one I ordered was this red real-time clock, and the battery was on the bottom, but I ended up taking it off. This is a DS3231, but this one for some reason just didn't work very well. It wouldn't keep the time, it kept losing its time and things like that. So the one that's actually in the watch is a black version of this, and it had a different battery and things like that, and it worked a lot better than this one. So I'll leave that one in the description. The next and most obvious piece is the actual Neopixel Ring. This is a 12 LED, multicolored LED matrix ring, and I will also leave a link where you can order one of those in the description. The next piece is the actual LIPoly battery, and as you can see, it is sewed in here real tight in between the two pieces of fabric in the wristband, and this one hardly fit in there. As you can see, it actually is still coming out from the edge, and it's just running right into a cut in the board. And then also the whole wristband itself, I'll leave in the description. I really liked how that looked. And the lily pad switches are what I used for the buttons. And this came with two already connected together, so all I had to do was sew that onto the band. And then there's the actual wooden circular board that was used, and that was from a pack of wooden nickels. It's 1.5 inches, and I'll leave a link in the description where you can get some of these. It's not the exact brand, but it should work just fine. And I just cut out a circular piece here, so you can fit the RTC chip in there, because there's a battery underneath them that you need to just make a hole there. And it was pretty fragile, so some of them I actually ended up breaking. And then the other holes that I made were on the sides, so that I could sew onto the wristband, that side and this side, and then as well as a battery hole. The last parts are the pins for the charging port. These are just created from these, just a cut from that. These are the types of things that go onto, for example, this Arduino board, so that you can put into a breadboard. But in this case, I used it as a charging port. The other thing is the resistors. There are two 10K resistors in here. The other thing used is the actual wire in here. I used very thin wire for this project. That's because when I tried using regular wire, it was almost impossible to fit all the wires into one pinhole and things like that. So here you can see this is a very small 30 AWG wire, and you can find this in the description. And the last thing is the actual charger, and this thing is also in the description. I do not have, these are just female to female wires. I actually don't have a link to them right now. Maybe I'll look and see if I can find something. Hopefully you'd have something already that would work. So those are all the parts. So let's get on to the schematics and the code. So these are the schematics. So I drew up some schematics real quick. Hopefully it's not too confusing. I tried to make it the best I could. So the pink represents the pins that we just aren't going to be using. This is the DS3231 real-time clock. This is the actual Arduino board, the AT1085. This is the battery and the Neopixel Ring. So this would be the main part to this project, and basically everything's going to be connecting up to this part. Now the red to 5 volt just represents that pin is going to be going all the way to the 5 volt pin on the ATtiny85. So here we have a 10K resistor before we put it to the 5 volts. That's just a pull-up resistor that's required for the real-time clock to operate. Now the ground, this symbol just represents that it's going to be going, a wire will be running from here to the ground on the ATtiny85. Now at the actual battery, we see we have a direct source to the battery, and that's where the charging port is. This is actually open to the battery at all times. And then we have this going to the 5 volts on the board, and then the negative side goes through a switch first. Now that's the switch that's on the side of the watch, and then it goes to ground. And then everything else shouldn't be too complicated. These are the two lily pad buttons, and these two pins just go straight to 5 volts. And then this one goes to pin 1 on the Tiny85, and this one goes to pin 4. And make sure you have the wires in the correct position. For example, on the SCL pin on the real-time clock, be sure that you add the wire before the resistor and to the pin 2 and not after the resistor. And same thing with all the other ordering. Just be sure you get that correct. So this is basically the schematics. Everything's being used except the out pin on the ring and this pin on the real-time clock, as well as pin 5 on the ATtiny85. So the first thing in getting it set up so that you can program this watch or just this Arduino board in general is following this wiki. It has some great instructions on installing the drivers as well as installing the board. For installing the drivers, I'm on Linux, so I just followed this page, and it has the UDEV rules that I need to add to the UDEV files. For example, I'll show you in, I can open up the, this is the UDEV rules that it uses, /etc/udev/rules.d/49-micronucleus.rules. So for example, here are the UDEV rules inside of that, and that is what allowed the drivers to work on Linux. So in this example, after you change the UDEV rules or add them, make sure you either reboot or restart the UDEV rules. And then the other thing that you need to do is, well, one thing is you might need to run the Arduino program as root for some reason, some permission issue. Now I was able to fix this, but I honestly don't remember exactly what I did to fix it. I might have did this command, gpassword-a, and then your username and UUCP, but I honestly can't completely remember what I did to get that to work. So if you have any issues, just use the Arduino as root. If you don't know how to do that, just go into the terminal, type sudo and then Arduino, and then open the Arduino program. And the other part in setting this up is adding the board in the board manager. So here it talks about using this JSON file. So if you just copy the JSON file and from Arduino program go into preferences, and then adding it into the additional boards manager. So once you add the DigiStump board URL to the additional boards manager, you can go into Tools, Boards, and then go scroll up into Boards Manager, and then it will download the platforms, and then go up to the type and choose Contributed, and then install the DigiStump AVR boards, which I already have installed. And then once you get that installed from the Tools and then Board, find the DigiStump AVR boards, and the one that works for the watch and this board is the DigiSpark default 16.5 megahertz. So choose that, and then you should be able to then you should be set up in the Arduino program to upload and things like that. Now the next thing is actually getting the code for this watch. Now I have I will put this up on GitHub, and you can look at the code, but this is the code. It uses a couple libraries. It uses tinywire.h, and then tinyrtclib.h, and Adafruit Neopixel.h, and I'll leave those libraries in the description as well. And what you do with those libraries is, once you download the zip file, in order to install that library onto the Arduino program, or go into Sketch, include library, and then choose add.zip library, and just choose the library that you downloaded. Now for the actual code, all you'll need to do is grab that from my GitHub. Now let's just look at this code really quick. There is a lot to it. I've compacted it down a lot. It uses about 95% of the space on the Arduino board. So here we have the pin that it uses, which is pin 3. If we go back to the schematics, I can just show you. Pin 3 is going to the Neopixel Ring. So we have that, and then we have all these other pins set up, and then we have these modes. These are the different modes. For example, the time, the other time that I showed in the video, flashlight, the strobe light, and then the rainbow effect, and the brightness, and then setting the time, etc. And then there's the setup, and it sets all the pin modes, and it sets up the RTC clock, and then this is the loop, and it's constantly checking for button input, and then these are the different modes, methods for the different modes and things like that. The button interrupt, this is the checking method to check what button's being pressed, and if a button's being pressed, what to do. And then the show time, that's one of the modes, and all of these are just different modes. And then the clear pixel, that just clears the whole Neopixel ring. Now there's a lot to this. You might want to spend a little bit of time looking through this, but another thing is that the library, the Neopixel library, comes with a simple strand test. So if you just open that example and make sure that the pin is set to 3, then you can just test that. And let me just do a quick upload to show you how it works. So first of all, make sure the board's correct, and then we can do a verify to make sure that the code is compiled correctly and there are no issues, and then you choose upload. Now this is a little interesting. You actually have to unplug the watch and then plug it back in, and then wait for it to start uploading, and then there you can see that it has uploaded. And as you can see, this is the strand test that it is going through in the code. So you can do more than just have it as a watch. You really can program it to do whatever you want, and that's what makes this project pretty cool. Well, I guess that's about it. I have all the links in the description. I've got the libraries, the code, the links to buy stuff, everything. Now, I know that was a pretty long video, and there's a lot to this. It really is. It took quite a bit of time to put it all together, but in the end, you decide whether it's worth it or not. It's a pretty cool device, and I might consider maybe putting together some sort of kit or just all the pieces so that people can just buy all the pieces at once instead of using all the different links from all the different stores and things like that. So that's only if I get a lot of people that actually want that. So I'm not just going to do that if no one really wants it. But that way it would be a little bit less expensive. But so yeah, this is the final product, and I hope you enjoyed this video. If you don't understand it, then maybe you got something out of it at least. But thank you for watching.